Hey guys, Miss Marflack here. We're getting started with a new packet, and that packet is going to be on functions. Now, if you don't have a printer, don't worry. You can do most of this, actually, you can do all of these questions and everything in your notebook. Now we're going back and we're doing Algebra 2 review. We finished with the trigonometry. We're done with that. We've been working with the trig from September, so yay, we made it. And the Algebra 2 review can be difficult for some students because we're really focusing here on mastery. So the assumption is that you learned some of this or most of it, you've seen it before in Algebra 2, and now we're trying to master all these topics before you go ahead and use these important concepts in calculus. After we're done with the Algebra 2 review, we finish off marking period 4 with an introduction to calculus where you're going to see a lot of these concepts being used. Before we get to the packet, we're actually going to start in our notebook like Ms. Marflack always likes to do, and here we are. And our title is functions, and we're going to be taking a look at our first lesson, and that's interval notation. Now in interval notation, we do have two symbols. Our first symbol is our parentheses. You could see them here, and we use our parentheses when we're not including our endpoints. That's going to be an open circle, or where we're used to seeing it in that inequality notation, we are not inclusive, no line under, open circle. That's when we use our parentheses. And then our next symbol is going to be our brackets, and here you could see our symbol for brackets, and we use them when our endpoints are included, and we do have a closed circle maybe on that graph, and then in your inequality you are inclusive with that less than or equal to, greater than or equal to, including those endpoints. And then lastly, we always use these parentheses at infinity or negative infinity. We never include infinity or negative infinity. Now we're going to take a look at a chart here, and the chart's going to outline all of the possible cases that we can have with interval notation. Before we get started with the chart, we're just going to let A and B, our two variables we're going to be using in this chart, we're going to let them be real numbers, meaning they could be radicals, they could be irrationals, they could be any number as long as it's a real number, and then such that we're going to have one condition, and that's going to be that A has to be less than B. So we're going to be writing A on the left-hand side and B on the right-hand side because we always write our interval notation least to greatest. We're going to have one column here, and that's going to be our interval notation, which is what we're really working on. And then our next column, is going to be set builder notation. Now you may not have heard maybe this term before, but once I show you the set builder notation, you would have at least seen most of it because it contains the inequalities that we're used to seeing with Algebra 1. And then lastly, we're going to go ahead and we're going to graph them. Now these are going to be in no special order, but just for the sake of kind of keeping track here on which ones we've done, I am going to start off with number 1. All right, our first interval is going to be an open interval for A and B, and with our set builder notation, we use those curly brackets to denote a set. This is going to be the set of all x values such that x is between A and B, and it's not inclusive of either or, open parentheses. And then we're going to close that set. And then when we're graphing, we have our A, we have our B, A is less than B, and then we have our parentheses, and it can be any x value in between here. Now, I do like to graph with the open circles, or closed circles. So I usually use these graphs on top. This is what they had in the textbook, so I'll show you both. So you can either use the parentheses or you can put an open circle here and an open circle there. All right, taking a look at our next set. That's going to be 2, and we're going to have now a closed set, and that's going to be all of our x values such that x is between A and B, but it can be A or B, okay? It can be inclusive of A and B. So when we draw it, you guessed it, we're going to have brackets here, or if you're like Ms. Marflack and you kind of like, and I have to fill this in, that we're being the values between A and B, or you can use those closed circles, and that's what we call a closed interval because it's closed on both sides. All right, now we're going to be going to number 3, and we're going to be looking at kind of like this either or situation. We're going to have a closed and then an open interval, and that means that we have all values of x such that x can be greater than or equal to A, but it has to be strictly less than B. All right, there's our bracket, there's our parentheses, and when we're drawing this interval, keeping in mind that the interval notation is the endpoints. So this endpoint is closed and this endpoint is open, and then it's the endpoint, so it can be any value in between here. That's going to be a closed circle, and then we have our open circle. All right, hopefully you're keeping up. We're taking a look at number 4. All right, and then now we're going to switch it around. We're going to have an open A to start with, and then we're going to have a closed B to finish with, and that's going to be the set of all x values such that x has to be strictly greater than A, but it can be less than or equal to B. And then when we're drawing it here, we have our A, we have our B, we got an open. All right, this is supposed to be a parentheses, open, and then we got that bracket close interval, and then really showing that I'm filling that in there. And then here we are, that's an open circle, and then there is my closed circle. All right, there's number 4. Let's see how many more I got for you. I think there's 9 in total. Yep, 9 in total. All right, here's the next one. We have A, and then we're going to go all the way to infinity, and keeping in mind those notes from earlier that infinity is never inclusive. This is our x values such that we can be any value from A all the way to infinity, which means x is greater than A, all right, but it can't be equal to A. So then here we are, we're going to have A, and then we have our parentheses, and then we're going to use an arrow to show that we can be any value greater than A. So we can be from A to infinity. Then we're going to have that open circle there and then an arrow. All right, taking a look at number 6, we have the situation where we have a closed, half closed, half open. This is our set builder notation, all the x values such that x is greater than A, or it can be equal to, because I'm including the A now. And then we're going to close that set, and then here I am, I have A, bracket, and then we're going to have an arrow. We can be greater or equal to A. Then we're going to have that filled in circle, and then the arrow. All right, I think I could I'll squeeze one more down here, one more. 7. Now we're coming from negative infinity, also not inclusive, and I'm going all the way up to B, and I'm not including B, which means that our x can be any value that is less than B. Keep in mind that your x is kind of like in the middle here. So notice how I'm writing the x is between, it's in the middle of negative infinity to B, so that's why I'm writing less than B, because B is on this side. And then I'm not including because this is a parentheses, so I'm going to have B here, and I have my parentheses, and it could be any value less than B, and I got my open circle, and I'm going all the way to the left, my negative infinity. All right, we're on 7 out of 9. Here we are, number 8. I think I wrote the number over here. Yes, I did. Okay, good. All right, now we have negative infinity, and then now we're going to B, except now we can be inclusive of B. And then now we're going to have that set builder notation. That's all the values of x such that x can be less than or equal to B. And then we're going to close that braces. And then here we are drawing that interval for us. There's B. We have our bracket. We can be inclusive of B, and then all the values less than. And then there's that closed circle, and then all the values less than. And then we made it. Here is the last one, and this is going to be our set of all real numbers from negative infinity to positive infinity. My infinities don't look that good. Maybe you could take your time and write them a little prettier. There we go. That looks a little nicer. All right, this is going to be our set of all x values, and this notation is going to be a little weird, but that's all values of x such that x is an element of the set, the real number set. All right, I know that's really confusing, but once again, I'll read it. X is the element of the real number set, or you can write all real values of x. And then when we're drawing that graph, that means x can be any number, which means that we're not going to have any endpoints. We just have arrows here. All right, no open, no closed circle, just 2 arrows. All right, that's all of our possible cases that you can kind of see. And then we're just going to go over one more thing before we jump into the packet, and that's what we call a union. Now, union is going to be the joining of 2 or more sets. So even though we went over 9 cases, you could start joining these sets together, 2 or more sets. And then the symbol we use is this U here. So you have one set off to the side like A, to B, and then we're going to union and join it with this set C to D and so on. All right, and then we're joining two sets together. We'll see more of that. I know it's a little confusing with the variables, but when we see some numbers, hopefully it'll make a little bit more sense. All right, moving on to the packet here. Like I said, if you don't have the packet or if you weren't able to print it out, please do not worry, just write them in your notebook. Now, as we're working through this packet, it's gonna be super important that we're looking at something, and the something we're looking at is that bottom page number. All right, while I'm assigning homework, I'm gonna be jumping around a bit. For example, like this is on the first page, but we're doing piecewise functions in the next lesson. So we're gonna be jumping around a bit, so really make sure you're looking at those page numbers. All right, I'm getting started on page 2 for us, and we have just, these rules here. If you want, you can rewrite some of the symbols, but we're not going to do this together. We're jumping into some examples because we already took notes. All right, take a look at example 1. Write the inequality in interval notation. All right, keeping in mind interval notation is those endpoints. So the endpoint I have, my A is -3 and my B is 2. I am inclusive of my -3 and I am not inclusive of my 2. So this is saying, x can be any number between -3 and 2, but it can be -3 and it can't be 2. All right, and then now here we are, write an interval notation and graph. All right, I'm first going to start off with the interval notation. I read this, x is greater than or equal to 4. So I'm starting at 4, and then x can be any number greater than 4, and I'm going all the way to infinity. Those are my two endpoints. And then I can be 4, so I'm inclusive of 4, and then I'm never inclusive of infinity. And then now when I'm drawing that graph here, I can put 0 just as a marker, and then I also want to put 4. I am inclusive of 4, and that could be any number greater than or equal to 4. All right, taking a look at number 3, write each interval as an inequality and then draw our graph. All right, now we're given this interval notation from -infinity to -8. All right, that means x can be less than -8. And it can't be inclusive of 8 because we have a parentheses, but x can be any number from -infinity to -8. All right, keeping in mind that this is written on the right-hand side, okay, notice that. That might help you a little bit. And then now we're going to draw our graph, and the graph is easier once you have the inequality. Putting that 0 in again for reference, just going to throw in that -8 there, and we're going to have an open circle because we are not inclusive of -8, and then any value less than -8. All right, taking a look at number 4, write an interval notation. Write the interval notation that describes this graph. Well, our interval notation is our endpoints, and then we're not inclusive of the -4, and we are inclusive of the 0. All right, so x can be any value between -4 and 0, can't be -4, but can be 0. All right, once again, I'm skipping this one down here, number 5. We'll come back to this in our next lesson. This would be a good time to pause the video, make sure you got all those 4 examples. All right. Now we're moving on to page 3, and we're going to do some examples from page 3. All right, classwork 1, write the inequality in interval notation. Well, we have those endpoints, all right, -6 and 12, and we are not inclusive of the 6, and we're not inclusive of the 12. All right, moving on to -2, x can be any value greater than 7. And if I want, I can switch this around as having the 7 on this side from least to greatest, right? That the x is bigger than 7, and that might help you write the 7 on the left-hand side and see that x can be any number greater than, and then that right-hand side is going to be infinity. I can be inclusive of 7, so we're going to have a bracket there, and then I'm never inclusive of the infinity. There's my parentheses. All right, here we are. Now I'm written in order from least to greatest. Y is less than 4, so my 4 is on my right-hand side. I'm not inclusive of 4, and then I'm coming from -infinity because I can be any value less than 4. Number 4, write an interval notation and graph. First, starting off with that interval notation, I'm written in order from least to greatest. So I have x is less than 6. So my 6 goes on my right-hand side. I'm not inclusive of 6, and I can be any value less than 6, and that's where I have that -infinity. And then now graphing, I am going to use my inequality here. I can put my 0, my 6. I have an open circle, and then I'm any value less than 6. All right, taking a look at number 5, we're not written in order from least to greatest. We're written from greatest to least, so I can switch this around just like I did in number 2. Now that kind of shows me that my -2 is on the left-hand side, and then x can be any number greater than -2, so I go -2 to infinity, and I am not inclusive of -2. And then when I go ahead and do my graph here, I throw in my 0, my -2, I have an open circle, I'm not inclusive, and I'm any value greater than -2. Taking a look at number 6, write each interval as an inequality and graph. All right, now we're writing an inequality given the interval. So our x values can be any value from 5 to infinity. So that means that x is greater than or equal to 5. Now I throw in that line there because we do have that bracket. Now you can write it in order from least to greatest, like 5 is less than or equal to x. And then that will kind of match the interval notation a little better with those endpoints there. And we are going to graph. So here I am doing our graph. We'll have 0, we'll have 5, we can be inclusive of 5, and then we're going to go all the way out to infinity. All right, taking a look at number 7, we're going from -2 to infinity, not inclusive. This means that x can be greater than -2, not inclusive. Or you can rewrite as -2 is less than x. So we go from -2 all the way up x, and we have no upper bound here. All right, no upper bound. And then now we're going to go ahead and we're going to graph. So I have my 0, I have my -2 open, and then x can be any value greater than. All right, going to that right towards that infinity. Taking a look at number 8, write the interval notation that describes the graph. All right, this is where we're going to see that union because we have two segments here. All right, I have this segment where I have from -infinity coming all the way from here, -infinity, and then I'm going and I'm stopping at -4, and I'm not inclusive of the 4. And then I'm unioning that with the -4 starting again and then going all the way out to infinity. So now I have two sets here that my x can be in either or set, and there's that u with joining the union. All right, same thing here. X can be any value less than 2. So we go from -infinity, reading left to right. We go all the way to 2, and we're not inclusive. And then we're joining that with the set starting at the x value 13. We can be 13, and then we're going all the way out to infinity. All right. Number 10, we're also going to skip, and that's going to finish it up for everything that we're doing in the packet today. I am going to do some more practice problems on a sheet, so don't go anywhere. This would be a good time to pause the video and make sure you have all of this down. All right, I do think that mastering the interval notation comes from repeated practice. So we are going to take a look at this sheet, and I'm going to go through some of these together. Now this sheet, the last page is going to be our homework. So please stick around, and here we are taking a look at number 1. All right, rewrite the inequality in interval notation and draw the graph. All right, I'm first going to go left to right, so I'm going to start with the graph. And here I have x is greater than or equal to 4. So there's my 4. I can be equal to 4, and I am greater than 4. Now I'm reading left to right, so my first endpoint is 4, and I'm going out to infinity. I'm inclusive of 4, and I'm not inclusive of the infinity. I like to rewrite this sometimes in order from least to greatest, and then you can see there it matches and no upper bound for x. All right, now x is less than 6. We have an open, and we're going to the left because our values are less than 6. So our first number is -infinity, and then we're coming all the way up here from the left up to 6, and we're not inclusive of the 6. All right, x can be less than or equal to -2. So we're inclusive of the -2, and we can be any value less than the -2. So reading left to right, no lower bound, which means I'm starting at -infinity, and I'm coming all the way to -2, and I am inclusive of the -2. Taking a look at number 4, x is greater than 8. Here's 8. I'm an open circle because I cannot be 8, not inclusive, and then I'm going to the right side. I like to rewrite this here, least to greatest, and I could see that my first endpoint is 8, not inclusive, and then my arrow is going all the way out to infinity. And then taking a look at number 5, x can be less than -10. So I have that open circle, and I'm going to -10. My first endpoint is no bound, that's my -infinity, and then I'm coming all the way up, and I'm stopping here at -10, and I have an open parentheses. These graphs are not drawn to scale, okay? they're not drawn to scale. I didn't put in any extra points, just a rough sketch there. All right, good time to pause the video because we're moving on. All right, now our goal is to write each interval as an inequality and graph. All right, so we're starting off here. We have from negative infinity all the way to -8. So I'll put -8 here. And my -8 is inclusive, and I'm coming from negative infinity, and I'm stopping at -8, which means that x can be less than or equal to -8. There's my upper bound and no lower bound. All right, taking a look at the next one, we can go our x values anywhere from 5 to infinity. So I'm starting at 5. I'm inclusive of the 5 because I have that bracket, and I can go all the way up to infinity. All right, this means that 5, our left-hand bound, is less than or equal to x. All right, x can be any number greater than 5. And then when I read this way, x is greater than or equal to 5. All right, taking a look at this one, -2 to infinity, -2. I'm not inclusive of the -2, so I have an open circle, and I go all the way up to infinity. Looking at that inequality notation, my lower bound is -2, and that's going to be less than x, and I can't be equal to x. Or I can write x is greater than or equal to -2. And then now we have number 9, -10, and we are inclusive with that bracket, and we can go all the way up to infinity. So my lower bound is -10, and then x can be any number greater than or equal to -10. All right, so I've done more than enough examples. Now it's time for you guys to do some practice, and this is going to be your homework for tonight, and it's going to be completing this chart. Now, in this chart, I give you something and then I want everything else. Sometimes it's easier to, if I give you the words, to start off with the graph and then go to interval notation, whatever works for you, but this whole chart does need to be completed. Now, interval notation can seem really, really easy, but once you start doing the actual problems, it can be tough thinking, okay, well, does my x go on the left? Does it go on the right? So really make sure that you go back through that whole video, and I did more than enough examples. So I want you to really take a look at those examples while you're completing this. Keep in mind the goal here is mastery, because this is an Algebra 2 topic, and we really are going to need it moving forward when we're talking about limits graphically. So I want you guys to master this topic, so go back through those examples and please do your homework. All right, I'll see you guys soon. Make sure that you're emailing me if you have any questions.